Hello, everyone. Welcome to the series of Greek calculus. And on today's video, we're going to talk about classification of numbers, exponents, and radicals. First, I'm going to talk about our journey map. So the first unit, as you can see, is algebra review. And then we go to functions, which is the unit 2. Unit 3 is polynomial functions. Fourth, rational functions and exponential functions. And then logarithms, trig identities, and applications of the trig identities, analytic geometry, systems of equations, and then sequence and polar and parametric equations. Well, it's not fixed yet because I haven't put vectors. Maybe there will be vectors in the future videos. And again, it's the journey map is not yet fixed. So first, I'm going to talk about classification of numbers. So the classification of numbers, we're gonna mainly be in the real numbers, okay? So they are real numbers, real numbers, okay? So real numbers is like all the numbers in the world, like except complex numbers. Two, like two, negative root two, root two, 4/3, and then let's say pi. That's the real numbers and so on, okay. And then there is inside of the real numbers, it's not uh, it's not like inside of it it's rational, but it's its own like space, which is irrational numbers. So irrational numbers is the numbers that can be expressed into fractions, like root 2, pi, okay, and then Euler's constant, and then root 3, and 1 over root 3, and so on. Those are irrational numbers. This is irrational. Rational, this is real. And inside of the real numbers, there are also something called rational numbers, which is Q. We don't denote it as Q. So Q, rational numbers, is like 4/3, 7/2, 0.5, and etc. Okay. And then inside of the rational numbers, there are whole numbers, or no, integers. Integers are like 4, 2, -2, -8, and so on, including 0. Next, we're going to go to inside of the integers there exist whole numbers. Like whole numbers, there's no specific denotation. Let's say this W. It's 0 and all the positives, integers, excluding negatives. Those are the whole numbers. And inside of the whole numbers, there are natural numbers. So natural numbers are this set 1, 2, and 3, 4, excluding 0. So it's just 1, 2, 3, and so on. So this are the naturals. These are the whole numbers. These are the integers. These are the rationals, irrational, and the reals. So the rationals, integers, whole numbers, and natural numbers lives in the real. Okay, so write this down. So the whole numbers, rationals, I mean. So rationals, so naturals, I mean, naturals is a subset, okay, Subset. Yeah, a subset means there exists like a portion of the numbers inside of the, let's say, A subset B. So if B has like 1, 2, 3, and A has 1, so A is a subset of B. Okay. So and the natural numbers is subset of W, which is the whole numbers. Okay. And the whole numbers is a subset of the integers, while the integers is a subset of the irrationals, not rationals. I mean the rationals, which is Q. And then the rationals is a subset of reals. And notice that the rationals is not a subset of in the irrationals. So the irrationals actually, so the irrationals I is itself subset of R. So that's the classification of numbers. Now we're gonna go to exponents. So exponents take form x to the power of n. If we have x to the power of n times x to the power of m, if they have the same base, we do this. We add the exponents plus m. If you remember the rule. So this is multiplication rule, and there's also the division rule. X to the power of n over x to the power of m is equals to x to the n minus m, and also x to the power of minus n is the same thing as 1 over x to the n. Okay, and x to the power of n times to the power of m is the same thing as x to the power of n times m. Okay, and if they are different bases, like a times b to the power of m n, okay, well, you can't necessarily do anything with it. So if they have the same powers, well, you can group the power of k. Okay, again, these are the rules of the exponents. Hopefully I didn't forget some. Let's x to the power of, yeah, these are the rules of the exponents. And also, if you encounter the same uh, exponents but different bases and they divide each other, let's say a to the k over b to the k, that means it's the same thing as a to the k minus k. Sorry, it's not the same. A over b to the power of k. Okay, and well, that's it for the exponents. So this is the exponents. Let's take an example. Okay, let's take an example. X squared. Oh yeah, the I forgot the distributive rule. So if you have x to the a times, let's say, x y plus, say one of them is x, okay, x, and this add by x, no, different, the same base but different exponents, x to the b c, then it shows that x, well, this is x to the b plus a plus x to the c plus a. Okay, now an example question would be x to the n, let's say x to n times x to the power of 3n over x to the power of n plus x to the power of 2n. Okay, so we need to simplify this. As you can see, on the numerator we have multiplication, so we can add them at the exponents. So x to n plus 3n, which is 5n, over x to the n plus x to n. Well, we cannot necessarily add them. Instead, what we can do is actually factor out x to the n. How? So if we factor out x to the n, well, x to the n times 1 would be x to the n, and then add by our x to the n. So x to the n divided by x to the n, that must leave x to the n minus n, right? So it will be x to the n. So it will be x to the n. And then we cancel these. X to the 5n minus n, okay, minus n over 1 plus x to the n, which leaves us with x to the 4n divided by 1 plus x to the n. That's the simplified version. For the questions or the practice will be the end of the unit. So we're going to get to the practice at the end of the unit. And then the third thing we're going to review is radicals. So radicals are expressions like root a, root 2. This is called a radical. So more generally, a radical is a root and fruit a to the power of n. Okay, where we can express this as a to the power of m over n, m divided by n. As you can see, this is if we write out the rules for exponents, which are the radicals, will be the same as the exponents, the rules of exponents here. So I don't need to write the rules again. So I assume you will know. For example, if we have the same base, a to the power of m over n times by a to the power of n over m, we don't times the exponents, we add them. So a to the power of uh, m over n plus n over m, which means m squared plus n squared over n squared, or all divided by nm a to the power of n. Okay, let's say we have 2 root a to the power of 4, okay, and then we times it by a squared over 4th root a squared. How do we simplify this? First, we make it into the exponent form, which is a 4 divided by 2 times a squared over 2 a 2 divided by 4, which we have a 2 times a2, a to the power of 2 over a to the power of a half. What we have is a to the power of 4th divided by a to the power of a half, which is equals to a to the power of 4 minus a half. What we get is 8 minus 1, 7, which is 7 over 2. Okay, if we express this as the radical, we have root 2 root a to the power of 7. Okay, now what if we have a radical in the denominator, like 1 over square root of a? Well, in math we don't like radicals in the denominator, so we must times the numerator and denominator by itself, so square root of a. Why? Because as you can see, root a, if you have m, no, n root a to the power of m times n root a to the power of m, that would be a to the power of n over m plus n over m, right? Which we have a to the power of what? 2n over m. If our n was equals to 1 and our m equals to 2, so which in this case, which is root, so a to the power of half, that means times a to the power of half, that means 2 times 1 over 2, which is to the power of 2, we have 1, a to the power of 1. Okay, now we have root a over a. Well, I believe that's it for this video, and I hope to see you guys at the next video if you're interested, because I like I'm not used to making videos or teach videos without like an actual person being here. So hope you guys understand and I could teach well. I'm sorry for the handwriting because my what my writing tablet is broken. I don't know why. So well, that's it for this video. I thank you. See you next time.